Hi everyone, my name is Kaitlin Cho and I'm from the Bay Area, California. For my Polygence project, I was happy to work with my mentor Kristen in researching the capabilities humans have to inhabit Mars, specifically focusing on agriculture. It's amazing to think that we are able to see images of the surface of this red planet over 100 million miles away. This sums up my motivating interest for this project, which were the endless possibilities when exploring the universe. The reason I chose a specific focus on agriculture was because agricultural practices are already so great on Earth, and I thought it would be interesting to see if we could take those practices onto this very different environment. But why is this research important to society? Space exploration is becoming an increasingly important industry for the economy on Earth and the future of humans. Because of climate change, 3.3 billion people's lives are highly vulnerable, and scientists predict that parts of Africa and Asia will be uninhabitable by the next century. Due to its similar location and properties, Mars is a prime candidate for finding a second Earth due to these concerns. With all this in mind, my thesis for this research paper was creating a system of agriculture on Mars requires further knowledge of its existing conditions and how technology can be used to help humans expedite the process. The first subtopic I'd like to discuss is water and how we can use it to our advantage on Mars. So currently 5 reservoirs of Mars hold water, the essential liquid for life, which are the atmosphere, surface water, water absorbed in the soil, hydrated minerals, and subsurface ice. These are all shown on the diagram and spread out throughout Mars. Water is most present at the northern and southern poles. These locations host a variety of forms of water, but some forms are more abundant than others. For example, in the case of frost, carbon dioxide frost has been more commonly found than water-based frost, making water-based frost more rare. Another observation scientists have been keeping their eye on is recurring slope lineae, or RSL. Some think this phenomena might be sand or other granular material, but these patterns appear more in warmer seasons, where specifically liquid water is more common, suggesting the connection. And in the photos, you can see the mesmerizing patterns that this RSL creates, which is why they are so intriguing to scientists. Researching the surface of Mars has also led to discoveries regarding the presence of water in the planet's past. There have been different amounts of water through the Mars's history, from ice ages to oceans, and currently Mars lacks the water it did in its history. The problems of finding water on Mars are that liquid water is difficult to locate, and water from frost needs filtering. So the problems are that we need better technology in order to use all the resources of water we can on Mars. And on the other hand, the solutions are that looking at the ice at the bottom of Martian craters might make it easier to access, and we can use cameras to better detect the water. Next, I want to discuss regolith, which is the soil-like substance on the surface of Mars. So it's just a fancy name for the soil. Regolith has many of the necessary components for life, elements like nitrogen, hydrogen, that are very important to life on Earth. Additionally, clay minerals and salts are also there, signaling that there might be water in the regolith. However, there are harmful substances such as perchlorates and sulfates that prevent agriculture from forming on Mars. It also has a very different pH than that of Earth, so if we would bring agricultural practices, they would have to change quite a bit to adapt to this new pH. The most crucial barrier that prevents agriculture from succeeding on Mars is perchlorates, because these substances are toxic to humans. If agriculture was grown in the current Martian soil, it would have toxic chemicals that come from these perchlorates, and they would be toxic to humans. Perchlorates are mostly from solar radiation because they form from UV radiation and chlorine. The solar radiation also has another problem. It makes the soil self-sterilizing and oxidizing, so it is very difficult for life to form, and particularly microorganisms cannot form in the soil. Lastly, I would like to discuss atmosphere because it is a very crucial part that encapsulates the whole planet. So manipulating the atmosphere is important to successfully do agriculture. Elements like nitrogen and oxygen that are heavily concentrated on Earth's atmosphere are less common on Mars. This creates an issue for both agriculture and humans' survival on Mars. Another difference between Earth and Mars is the magnetic field. Earth has a magnetic field that encapsulates the whole planet, but on the other hand, Mars has small, localized magnetic fields. When plants are grown in weak magnetic fields, it impacts their ability to properly control root functions. To combat this, scientists can find local magnetic fields and use them to optimize growing for agriculture. In terms of climate and weather, it is very different than that on Earth. The most crucial point preventing human civilization and plant growth is dust storms. Dust storms are very harmful weather and they shift the atmosphere. Dust storms are formed from the pressure gradient in the atmosphere plus the carbon dioxide buildup, which creates the motion of dust and harms a lot of the environment on Mars. Dust storms are an example of periodic weather, much like the seasons on Earth. We can take advantage of this periodic weather and track when the dust storms come and go to make sure we are landing on Mars at the best places and making sure we know what's coming when we have weather events. So volatile pressure is a very big problem in terms of regulating the atmosphere on Mars. There are long-term and short-term variations, such as normal condensation and sublimation on Earth, but also over time, dry ice behavior of the atmosphere due to solar wind, because the solar wind strips away some of the particles on the atmosphere, making it less protective of Mars itself. Another big problem for humans especially is the lack of oxygen. Although this will be discussed in the technology portion in a little bit, a solution to this oxygen is a mechanism called MOXIE, which is on the Perseverance rover. MOXIE takes in resources like carbon dioxide and splits the carbon dioxide into oxygen and carbon monoxide. Scientists are finding ways to make sure the carbon monoxide is also used for a good purpose, so we are not making any more harm than there already is. Speaking of the technology, the Perseverance rover is a great example of how we are improving our innovations that we are sending to Mars. A little bit about each of the mechanisms on the Perseverance. So RIMFAX detects water, salts, and ice. META tracks climate and weather. MassCanZ and Pixel use spectrometers and cameras to detect chemical signs. And put all together, we can see that the technology is already improving and just needs to keep improving for us to successfully live on Mars. So all these put together on the Perseverance make it an optimal research robot for us to gain more knowledge on Mars. Although Perseverance has sent a lot of technology to Mars, people here on Earth are finding other ways that we could improve Mars for civilization. For example, we could have an insulated greenhouse where we block out the harmful atmosphere and have soil that is free of perchlorates to make sure that the organisms have the best chance to grow. We can bake soil, engineer genes of extremophiles, and use geothermal heat for energy to improve the agriculture in a way that is much different than Earth. Altogether, the technology needs to be improved if we are to finally find civilization on Mars. Innovation beyond agriculture is already making progress on Mars and other places in space, whether it be Axiom Space's spacesuits or NASA's work on a hopeful Artemis 3 mission to the moon. To use the words of NASA, there are three main goals for Mars exploration: explore the potential for Martian life, support human exploration of Mars, and discover dynamic Mars. Through further research on the water, regolith, and atmosphere of Mars, scientists can learn more about the capabilities of life on this planet, and these goals from NASA can definitely be achieved. Thank you.